Hi, Chem students, it's Mrs. Hessel, and welcome to today's lesson over half-life. Please have out your notes. I'm starting on page 10. You'll also need something to write with and a calculator today. Okay, so what is half-life? It's the time it takes for half of a sample to undergo radioactive decay. Half-life can vary greatly depending on the isotope. The shorter the half-life, the more highly radioactive the isotope is. So our examples, we've got the half-life of polonium-212 to be 3 times 10 to the negative 7 seconds, so super short. And then we have the half-life of uranium-238 to be 4.5 billion years. It's a really, really long time. So we're going to say that the polonium is a lot more radioactive than the uranium. The main purpose of today's lesson is for you to learn how to calculate half-life. So we're going to do a couple of examples, so be prepared to follow along and pause the video, try some on your own, and see how you do. All right, number 1, a radioactive isotope has a half-life of 330 years. If the initial amount of the isotope was 800 grams, how much remains after 1,320 years? Okay, I'm always going to give you this little chart on tests, quizzes, etc. in order to do half-life calculations. So learn how to use the half-life chart. The first column is the number of half-lives, which increases 0, 1, 2, 3, 4, 5. The time elapsed in years is the next column, and we've got mass in grams as our last column. So realize the number of half-lives and the time elapsed is always going to start at 0 with our initial mass, whatever mass we're starting with. So since the half-life is 330 years, after one round of half-life, 330 years has passed, then what happens to our mass? Well, it's called half-life for a reason, because every time we go through a round of half-life, it's going to cut in half. So 400 grams will remain after 330 years. Well, this pattern continues. After the second round of half-life, and another 330 years has passed, so we're at 660 years, the sample is going to have decayed again. So we're only going to have 200 grams left. After 3 rounds of half-life, 990 years will have passed, and our sample will have cut in half to 100 grams. After 4 rounds of half-life, 1,320 years will have passed, which is good. That's what the question's asking about. And our sample will have decayed in half again. So I only have 50 grams left. That is my answer. 50 grams remain after 1,320 years. Let's try another one together. The same isotope with a half-life of 330 years has been decaying for 1,650 years, and 31.25 grams remain. What was the initial amount of the sample? Okay, so I'm giving you the same isotope, but I'm asking a different question. I'm asking what was the initial amount of the sample. So the initial amount is going to be here. Remember, the number of half-lives is 0, and the time elapsed is always going to be 0. They told us this is the same isotope as the last one that takes 330 years. So after 1 round of half-life, 330 years will have passed. After 2, 660 years will have passed. After 3, 990 years will have passed. After 4 rounds, we've got 1,320. But after 5 rounds is when we'll hit our 1650 mark. So it says that after 1,650 years, 31.25 grams remain. But at this time, it's asking us for our initial amount. So if going down on our chart, it decreased by 2, going up on our chart, it's going to double. So after 4 rounds, we can say we had 62.5 grams. After 3 rounds, we would have had 125 grams. After 2, we would have had 250. After 1 round, it would be 500. And then at 0 half-lives, to get our initial amount, it would be 1,000 grams. Let's try our next example. A sample of a radioactive isotope that was originally 1,600 grams decayed for 25,000 years. If 50 grams remains after this time, what is the half-life of the isotope? Go ahead and pause the video. Try to solve this one on your own. When you come back, I will explain it to you. Okay, welcome back. So hopefully you knew that the number of half-lives and the time elapsed always starts at 0. It told us that our sample was initially 1,600 grams. Okay, it said that this decayed for 25,000 years until 50 grams remained. So what I started with is I took the 1,600 grams and I divided it in two until I got to 50 here. I knew that at 50 grams, 25,000 years had passed. And for that to happen, 5 rounds of half-life had to have occurred. So what I was able to do was take the 25,000 years divided by the 5 rounds of half-life and figure out that each round of half-life was 5,000 years. So 5,000, 10,000, 15,000, 20,000, 25,000. So my final answer is 5,000 years equals 1 half-life. Okay, let's try the very last sample in your notes. A radioactive isotope with a half-life of 3 minutes decayed from 100 grams to 25 grams. How much time elapsed? Please pause the video. You can do this one by yourself. When you come back, I'll explain it to you. Okay, welcome back. Again, the number of half-lives and time elapsed always starts at 0. Our mass was 100 grams. So it decayed to 25 grams. So 100 divided by 2 is 50, divided by 2 is 25. So this was really easy to figure out that we only went through 2 rounds of half-lives. If 1 half-life is 3 minutes, then 2 half-lives would have to be 6 minutes. So 6 minutes would have been the time elapsed. I hope you found today's video to be helpful, calculating the number of half-lives. You got some practice to do in your practice packet. If you need extra assistance, please ask your teacher. Have a great day.